Okay, so this is lecture number 7. We'll discuss about the language and also the this for document. Topic is thing because we need to know what is the format of the document so that we can extract information such as siapa dia punya author, what is the title of the document, when was the document created, and what is the content of the document. So for us human being, we can understand by reading, but when we present the document to the system or to the computer, they need some kind of guideline. Okay? So what we will discuss today will be metadata, document format, text properties, and document pre-processing. So when we talk about the document, the document usually denotes a single unit of information, like one paper, one news, or one email, or one report. So that is considered as one document. And of course, they have their own syntax and structure, grammar, format. Okay? And we also have the semantic, which refer to the meaning of the content of the document. So kita ada dua, satu is the structure and the other one is the meaning or the content of the document. So when we look at the presentation style, we will have the grammar or the structure, and we also have the content. So when we have the syntax and the structure and the content, it will be related to a specific application, specific idea, or specific concept. Okay, so for example, if we have this document, so it contains text and other media, for example, images or even video or even audio. So we will give them the syntax, which is how do we present. So this is more into the presentation style. And based on the presentation style or the grammar or the structure, so we will be carrying out all this information when we present the document. And of course, we also have the content, which is the semantic, or in other words, it is called as meaning. Okay, so sometimes we have one or more elements, and the structural element can have fixed formatting style. So that means every paper too, they have fixed formatting style. Okay, so for example, if you look at this chapter 6, so if you look at one particular chapter, you expect to have all the chapter 5, 7, 8, 9, and so on will have similar format. So they have the chapter number, the title, who is the author, and the section should be similar, like introduction, and then later on material and methods, and then experimental setup, and so on. So this can be done by using the formatting tools called LaTeX. So if you ever use this one, this is used for scientific writing, because this is in scientific writing we have formula, we have fixed formatting. In most of the publisher, they use this LaTeX format in order to produce their journal. So you will have similar format like this, and it's easier for them to edit, and then without having to worry about the format. Okay, so for example, like this is how we write in LaTeX. So we say this is the section. Let me highlight. So this is the section, this is the label, and then this is the start, and then we are citing from this reference, So when we actually execute this LaTeX document, we'll have something like this. So you see this is the section, and this is for it start, and then the citation is here, so and here. So it tells you what they cite from. Okay, so here, and then where is the introduction by looking at the keyword here. So by having this format, the system will be able to detect which one is the introduction, which one is the section, which one is the citation, and so on. So easier for them to extract those information. So this is in LaTeX. Very useful when you write a paper for journal. Okay. So for a query in the search engine, it can be considered as short piece of text. So it's different from the normal text because in the query, we usually use short term. Okay. So for us to present to the system, they need to have some kind of context on how the term being used. For instance, if we type bank, the system will not be able to determine whether bank of river or bank account. So they need to look at how the term bank is used in the sentence. Then they can make the assumption whether we are talking about bank of river or bank account. Okay. So that's why we need to know about this metadata, because this is the information about our data. Okay. So metadata is the information on the organization of the data, how do we organize them, what is their relationship, and so on. Okay. So I believe you have seen database. So database, normally they have tables, and then they have rows, and then they have column. So the column is the features, and then the rows will be your data. Okay, so this is considered as one table, so it might be linked to another table using primary key. Okay, so this is in the database, but in the text document, the information that we normally seek for is who is the author, when was the paper published, who is the publisher, and then how many pages, and what is the topic or content of the text. So these are the information that we need about the document, because we can use this one to retrieve our document. So when we look for certain document, whether we type the author or we type the topic or the content of the document. So metadata is associated with most document and text collection in terms of this. So a long time ago, they used this catalog card in order to store the information about our book in the library. So we can find all the information where they put the book, what is the title, what is the library control number, who's holding the book, and so on. So when we have enhanced the tools to store the information about the book, or we digitize all this information. Okay, so in order for us to store the information about the document, we need to have this semantic metadata in which it characterize the subject matter within the document content. So which means that we need to digitize or insert what is the content of the document. Okay? And it's normally associated with a wide number of documents, because when you have few documents, so you can perform clustering or you can form grouping to indicate that a few documents talking about the same topic. For example, 5 documents talking about political science, 3 documents talking about sports, and so on. So this is machine readable cataloging record, so most used format for library. So it includes several distinct attributes of bibliographic entries, such as what is the title, who is the author, where is the paper published. So this is the format of the machine readable cataloging record, so in which they are all digitized. Okay, so we have all the information here. So why do we need this? Because this is the short introduction of the document that we have, so we can have a look at this card by using exact matching, and we look for the author, or we can have some part of the title, so we can retrieve the document later on. Okay. But what about the data that we have in the web? How do we associate any of the document that published on the web? So nowadays we have more information published on. So this is very important, because the web page is used for various purposes, cataloging and content rating. We also have and digital signature, because every document on the web, they must have IP right, meaning that you cannot simply copy, and they have digital signature, and in most cases they describe item related to electronic commerce. Okay, so all the product that we have on the market, on the web, they are all described by using a document or a brief description of the item. So how do we keep track what information that we have on the web? They use this RDF, Resource Description Framework. So this is a new standard for web metadata. So this is metadata for web document. Okay. So how do we use this one? We basically look at the because when we type the URL or the URI or the URN, so that specify some properties here. For example, if we type the whole thing, URI, Uniform Resource Identifier. So inside this URI, we have URL. So in most cases, only given this URL, which is the location of the uniform resources. But when we click inside the landing page for this, they will give us this. And in some cases, we don't include this HTTP. So this is called the uniform resource name. So this is the name. This is the identifier when we include the protocol. And if we do not include here, so this is only the location, the landing page. So that's why the name of the website determine the type of resources that we have. So for example, how do we define a document that belongs to a certain author? So we use the object types which refer to resource, property, and statement. So how do we define this? So for example, in RDF, they use three-tuple representation. So we have predicate, which is the type of relationship that we have, and what is the subject and what is the object. So in this case, we are saying that, okay, we have this resource, which is the author. No, this is the resource, and the type of relationship is the author, and this is the value. So we can have that. So this is in the resource description framework. They call it a semantic web. So they use the three-tuple representation to relate the resource that we have and what kind of relationship that we have, and then what is the value. So this is just a brief introduction on how do we create information for the web. Okay. So now we go into the text property, because as you know that how do we know that one term is more important compared to the other term? So we use information theory. Okay, for the information theory, we are looking at how we capture how much information is there in a given text. For example, this. We have this one carry no. So we can use the information theory to define how much information that we can have for certain term. Okay. So for the entropy, because we use the entropy to determine how important is the term. Okay, how much information we carry. Ataupun, okay, for example, if we have this x, this is one term lah. This is y. If we are able to, if this one is usually used in the document, that means the certainty of this is very high. So that means easy to pick. But if this is very seldom, that means this one carry more information. So for example, like this one appear many times in our document, right? So that means this one has meaning. Okay, so the number of bits used to represent this is very low. Okay, we go to this theory entropy. So suppose that we have the entropy of a whole text like this. So we have this term and we have symbol. Okay. So based on the entropy we have, okay, for the term t here, we can compute the entropy based on probability of the symbol t that we use in our text, and then we sum up them together. Okay. It is important to note that E is a property of the model. So that means this is depending on what word you use for the model that we have. So it depends on this. And this formula, this entropy can be rewritten to this. Because if we assume that if the model always assigns probability pi to the alphabet symbol si, okay, where as I belong to the set of symbol, and this is, we always give them probability for this symbol. So we can rewrite this one like this. So that means we are taking the summation of the probability of the symbol I log base 2 times the probability of the symbol I. Okay. So let's take a look at how do we apply this. Okay. So for example, we have this term, right? So we want to know what is the entropy for this. So we will look at how many times A appear, 3 times, B 1 time, C 1 time. So we calculate the probability of each other. So this is actually 3/5, 1/5, and so on. Yeah. So when we apply the formula, the entropy formula, so we calculate, let me get that formula here. Okay. So we repeat the formula, so we have the minus here, and then this is the summation of all the term that we have, all the symbol that we have. So this is the first one. So A, this is for the A, this is for the B, this is for the C. Okay. So once we compute this one, so we 0.37. So meaning that we have 1.3 bits to represent this. So bits is number of bits lah. Okay. So remember that we have binary 0, 1, 0, 1. So bit here, meaning that we need to use 2 bits. So the higher the entropy, okay, the higher is the entropy, the more unpredictable the text is, means there can be more meaning. So in this case, 37 bits indicate a moderate level of predictability. So meaning that if you have high entropy here, that means they carry more meaning. Okay. So your exercises are given this, you mesh, you compute the entropy for each one of these, and using the formula here, you determine which one carry more meaning. So how do you determine this? It depends on the value of your entropy. The higher is the value, the more information that we have. So that means more important. Okay. So this is the type of question that will be in your final. So that is, we talk about the information carried by the text itself. For text properties, for modeling natural language, we normally have to go through certain process, but when we provide the document to the system should be able to tokenize or separate the term or word in the document. So they use a symbol, blank space, that separate the words, and then we also use symbol that can belong to wood. Okay. So in some cases, when we tokenize or when we identify the term that we have in the document, some of the words are very frequent. For example, let me show you the graph here. So this is the frequency of the term. So some of them are very high and some of them are very low frequency. So in most cases, when the frequency is for certain word here, we normally don't include this one because they do not carry much information. Okay. So how do we compute that one? It is basically this. So how are the different words distributed inside each document? So we use the zip law. For this law sets the frequency of the I most frequent word. So for example, like this is the most frequent term that we have. And then normally if your second one, for example, if I have F2 here, so this is equivalent to F1 divided by 2. This alpha is 1. So it means that the frequency of the second last one is half of the last one, right? So if we have 3, so that means the frequency of the third word is 1/3 of the first one. So that is the meaning here. Okay. So the second most frequent word has half number of occurrence of the first one. The third most frequent word has 1/3. Okay. So contohnya kalau I can give example here. So we say that the word X is appear 9 times. This is the first one. The second most frequent, contohnya Y. This should be 4.5 because half of the first one. And the third one, Z. So this one should be 3. Okay. So because this is the first one, the second one is equivalent to F1 divided by 2. So 9 divided by 2. Then the third one is F1 divided by 3. Okay. So that's how we get this graph. So in most cases, we will have a threshold which part of the word that we will not include in our term document matrix, because we need to reduce the word that we will be used for your term document matrix, okay, where you compute the TF-IDF. So that's how they select the term here. Okay. That's why the stop word that is most occurrence term, so they are called stop words. This one, we will ignore this because the frequency is high. So when you have frequency of high, so they carry less meaning. So we will not include this in our term document matrix. So this is more into how do we select term that is best used to represent the document. So we will not use the, by, and so forth. Okay. So when we look at this one, the bigger is the size or the number of alphabet used for the term. As it grows bigger, it will be stagnant at certain point, because the larger is the size, you will have limited vocabulary, for example, here. Okay, so this one is 45 letters. So when you have bigger size, that means you only can carry one vocabulary here. Okay, so very limited. But when you have smaller size, so you will can form different vocabulary. Okay. Okay. Now we go to text similarity. How do we? Because text similarity is important. For example, if you want to have the term document matrix, this is your Normally, this is your document, this is your term. Okay, so we want to be very selective. How do we select our term here? For example, we have salary, and then we have salary. So this is a typo, right? So do we include this one as two separate terms or one term? And can we measure the similarity between these two terms? Okay, so that's why we need to know this text similarity. Because at the end of the day, we will put the salary here. And then it appears two times if we say that these two are the same. If they are not the same, that means we will assume them two separate terms. So this is 1 and 1. So that's why it's very important to know how do we measure the similarity between two terms here. Okay. So we have this distance function. So the distance function is used to measure the similarity. So this is based on the number of positions with different characters. So for example, university and this one, so we have 1. So the distance between Malaysia and Malaysia side, this is 4. So this is called the Hamming distance. Okay. So the smaller is the value, the more similar they are. Okay. But this one, you need to have the same number of symbols. You cannot have different number of symbols. Meaning that kalau Malaysia ini ada 8, and this one pun must be 8. Okay. Okay. We also have the edit or Levenstein distance. This is the measure on how many operations that you need to do in order to make them equal. For example, this one, the edit distance for this color and color here is 1 because we only need one operation. So which is to delete this one or to add this U here. So 1. Okay, for survey and surgery, is 2 because we need to substitute B with G, and then we add and delete R. Okay, so then we can have similarity here. So this one depends on the number of operations that we use in order to make them the same. So the lower is the number of operations, the more similar they are. Okay. And we also have this longest common subsequent. So this one telling you if you have different number of symbols. So we want to know how, okay, the length of this one is 6. The length of this one is 7. Okay. So we want to know what is the longest common subsequent that we have between survey and surgery. So the answer is this, which is 5. Okay. So notice that you see this one, we have 6 and 7, and the longest one is 5. So if we have this one, for example, because if you want to know the longest subsequent here, the maximum we can get will be the minimum among these. Okay, but we have 5, so that means 5 is less 1 from this, so which is almost similar to these 2. Okay, if this value is only 2, that means they are not similar. But if this one going at maximum to 6, so that means the second one is, because they fulfill the length of the first one. Okay, so these are some of the methods used to identify or compute or quantify the similarity of the text. Okay. Yang tadi itu is more on word to word. This is based on two documents. Okay. So based on the two documents here, how do we know that the first document is the same as the second document? And what percentage of resemblance that we have? So for this one, we are looking at what is the intersection between these two documents, and then divide by the union of this document. So this is the resemblance, then the distance can be computed by subtracting the resemblance from one. So this will be the distance function. Okay. So let's give some example here. How do we use this one? Contohnya, we have 4 documents here, and we have A, B, C, D. This is the unique content that we have for D. This is the unique content for D2. Okay. This is unique content for D3, D4. So meaning that for duplication, we don't put 4 lah here. Okay. So we just take the unique one. So when we want to find the resemblance between 1 and 2, so 1 and 2 is 2/9. How do we come up with that? So basically, we are looking at this. So we look at how many common terms we have, 1 and 2. So that means we have 2 here. And then the number of unique terms when we combine here, which is 1, 2, 3, 4, 5, 6, 7 plus 2. So we have 9 here. So the resemblance for D1 and D2 will be 9. Okay, if you look at for this, on how many terms that one, we have D, and we have G, D, G, H, right? So this is no. This is between 1 and 3. So let's change that one. So we are looking at 1 and 3. Okay. So the common term will be 1 and 2. So that's where we get 2. So the number of unique will be 1, 2, 3, 4, 5, 6, and plus this 2. So that's how we get 8. Okay. And last one is 1 and 4. So unique term will be now common term will be B, D, right? So we have 2. So the union one will be 1, 2, 3, 4, 5 plus 2, we get 7. So this is the resemblance for 1, 2, 1, 3, 1, 4. Okay. So you may have to compute 2, 3, 2, 4, and then 3, 4. So how do we compute the distance? We just subtract lah. So the distance between D1 and D2 will be 1. So this is 1 minus 2/9. We get 7/9. So similar to this. So this is 1 minus 2/7. This is 1 minus 2/2. So this is how we compute the distance between your document. Yeah. So this is your some of the exercise. So maybe you can run through this one. Okay. So the last one is, okay, once we know how to compute the similarity between two words ataupun two documents, ataupun we can determine which term that we want to include in the term document matrix. So we need to know what is the processing that we need to do in order to capture all the term that we will be putting inside the term document matrix. Okay. So we have a few process here. So like lexical analysis, elimination of stop word, stemming, selection of index term, and construction of the term categorization structure. So what happened in lexical analysis is basically we are doing the tokenization. Okay, so we remove all this space, we don't need the number, happen, punctuation marks, case of the letter, we normalize them. So these are some of the lexical analysis. We tokenize the term that will be used for our term document matrix. So it's more like cleaning. We try to identify words in the text that we have. Okay, the second one is stop words. So we remove all the words that appear too frequently because they do not carry any information. How do we do this one? We compute using the entropy. Okay. So by using or by removing the stop word, we actually reduce the size of index by 40%. Okay. So for this one, to be or not to be, this one is carry no meaning. Okay. And also we need to do stemming, in which we are getting the root word only. For example, for connecting, connection, all coming from the same root word, which is the connect. So we will not consider this one as three different terms, but instead only one. So we will say if our document consists of all these three. So this is what we call stemming, finding the root word of the term that we have, and then we process them, include them in the term document matrix. Okay, once we have list of all the keyword, then we will do full text representation. And then what we do is we do keyword selection. So keyword selection can be based on the zip law. We put the we put the threshold. Certain word that have this frequency, we just eliminate, or we can use the entropy to say which word is the carry more information, we will include that. Okay. So when we look at the whole process, so we're starting from the document, we study or we analyze using the lexical analysis, where we tokenize them, and then we remove the stop word, and then we do the stem, and then we have the list of word that we can select to put in our or the list of terms that will be used to group the document. So if you look at the whole process, is basically each one of them will have specific purpose, which is to finalize the term that will be used to represent the document. So these are very important. For example, for stemming, we are cleaning the data. For this one, we remove document which carry no meaning. So this one, we use the entropy, or we can use the zip law. Okay. And then in the keywords, maybe we can look at the term that, for example, we only select term that having frequency above 3 or above 5. So we are reducing again. So if the frequency is low, then we will remove them. If above 3 or above 5, we will include them in our table. Okay, so that is for lecture 7.